Hi guys, this is Sakshi and I welcome you all to my editing platform, Way to Learn. So we are going to see thermodynamics and it's part 2 today. In my last video, we saw some important points from thermodynamics basics. So today we will see laws of thermodynamics. So zeroth law of thermodynamics is the first thing we are going to see. It is related to the temperature of the system. Okay, so if two systems are separated, like if I let me say that if A is a system and it is in thermal equilibrium with system C, and B is another system and it is also in thermal equilibrium with system C. So therefore, zeroth law of thermodynamics says that A and B will be in thermal equilibrium with each other. Okay, this is just a very simple law. Next is the first law of thermodynamics, very important one. It is based on the conservation of energy, a simple conservation of energy of the system, and you can find the internal energy using this first law of thermodynamics. So if I say like a heat dq is given to a system, then that heat can be written as du plus dw. Okay, du is the internal energy which is saved as internal energy, and dw is used the heat used for work done. Okay, so this is an important formula required. You can also write dw as pdv here, and you can get du is equal to dq minus pdv, an important relation. You have to remember all these relation, and you have to choose what kind of relation to be used to solve a problem. Next is the thermodynamic process, cyclic process. So during a cyclic process, internal energy is constant. Why? Because in my last video, I told that internal energy is path independent. It does not depend on the path. Okay, so for a cyclic process, U will be constant, then du will be 0. Then from first law of thermodynamics, we can write dq is equal to dw. And next is an isochoric process where V is constant and dV will be 0. Therefore, when dV is equal to 0, you can write dw is equal to pdv, where dw will become 0 and dq will be du. So, dq is directly proportional to the internal energy. So whenever the heat is given to the system, internal energy will increase, and whenever the heat is given by the system, internal energy U will decrease. So next process is the adiabatic process, an important process to know, where Q is constant over here and dQ will be 0. Okay, and then using the first law of thermodynamics, you can write du is equal to minus dw or equal to minus pdv. So this is an ulta relation because there is a negative sign over here. So if a work is done by the system, then the internal energy will decrease, and if the work is done on the system, the internal energy will increase. So this is a work done relation during an adiabatic process. It will be useful for you to note. So please note it down. And next is the isobaric process where P is constant here. So dP will be 0. Okay, pressure is constant. So dP will be 0 and work done will be PdV. dV is nothing but change in volume. So V2 minus V1. Okay, so next is the isothermal process where temperature is constant and the work done relation is given as 2.303 nRT ln V2 by V1. Okay, next is the free expansion. Here, free expansion is nothing but there is no change in the system. That is, the heat will not change, the heat will not enter from the surrounding, and nor the heat will leave the system, and the work will not be done by the system or on the system. So everything remains constant. Heat will remain constant, work done will remain constant. So that kind of system is called as free expansion. Okay, so when heat is constant, Q is constant, then dQ will be 0. When work done is constant, dW will be 0. Therefore, from first law, you can say that du is equal to 0. So du is equal to 0 says that u is equal to constant, which means u is path independent, right? So is when u is constant, you can say that the initial state and the final state will have the same internal energy. Okay, just remember this. This is for a free expansion. Next, these are few important formulae. You have to note it down, which is given by heat capacity. Okay, so if you see here, heat capacity is the amount of heat required to change the temperature of a sample. We do not have any particular value for the sample, but in the specific heat, you have to find the amount of heat required to increase the temperature of 1 gram of the sample. Okay, so there is a difference between heat capacity and specific heat. Next is the molar heat capacity. Heat required to increase the temperature of 1 mole. where Cp is equal to dq by dt and Cv is equal to dq by dt at constant pressure and volume. You have to note that. Next is the isothermal compressibility, important relation to note down. You can expect question from this side because in June 2019, formula was used, like not this formula but related to this this type of formula. Okay, it was expansion, I think. This is compressibility, it was expansion. So we have questions based on this because thermodynamics does not have very many formulas to remember. It has few formulas but important ones. So in this video, in my thermodynamics session, you can you can cover 90% of the formulas required to solve, and if something is missed, we will see in the problem session when we solve the problems, and if something new occurs, we'll try to know what kind of formula is that, and we'll write down in our formula notebook. Okay, so this is the isothermal compressibility bulk modulus, and next is the coefficient of expansion. This was asked in June 2019. Okay, a question from this was asked. And next is the gas equation during adiabatic process and isothermal process. So for an adiabatic process, you will have to remember the three gas equation. PV the whole power gamma is equal to constant. PV the whole power gamma minus 1 is equal to constant. P power gamma, P power 1 minus gamma is equal to constant, where gamma values are given already. It is the ratio of Cp by Cv, and is also given based on the degrees of freedom. I have already given you the values for gamma. Right. Okay. So if you haven't seen my videos, please go to my playlist, Thermodynamics and Statistical Physics. You can find the first part 1 of thermodynamics over there. So please follow, like from part 1, part 2, and part 3, and so on. Do not mix match yourself, like part 3 first, part 2 second, and thing. I'm going like I'm just trying to go step by step. So please follow that step by step. And if you haven't seen my classical mechanics playlist, please go check there, and mathematical playlist. I have completed classical mechanics and mathematical physics. So this is thermodynamics. So after thermodynamics, we'll see statistical mechanics. Okay, so we will be solving problems along with the concepts. Okay, so after I finish this concept, we'll try to solve the previous year problem for thermodynamics. So stay tuned for more videos. And yes, you have to remember for adiabatic process, here PV the whole power gamma is equal to constant, TV the whole power gamma minus 1 is equal to constant, T power gamma P power 1 minus gamma is equal to constant given, right? So in the question, if they have like any question like for an adiabatic process, and just see what is given in the question. If P and V is given, you'll have to use the first formula. If T and V, then you'll use the second formula, and if T and P is given, then you'll have to use the third formula. Okay, it is based on you how you try to use the formulas in the question given. And for an isothermal process, it is just PV is equal to constant. Okay, so I hope you like this video. So thank you. Share my videos, like my videos, and subscribe my channel. Share these videos if you like, and tell your friends that okay, if you like this video, then please share it with your friends too. And yes, hit the bell, because when you hit the bell, you're going to get the notifications of my videos. So thank you. Ta-da!